Okay, let's talk about LINQ in C#. So to have this discussion, we're going to use the example LINQ prime numbers. So that's what I'll be looking at here. And I'll open up the program file for that. And the first thing to know about LINQ is that it stands for Language Intrinsic Query. In other words, it's a way to access data in a language-consistent fashion. So rather than using, say, one approach to looking at an Excel spreadsheet and another approach to getting the data out of a database and a third approach for dealing with data structures, we're going to use the same syntax every time we want to get information out of a data source. And so that decouples the structures used to store the data from the code used to access the data. So this is another example of separation of concerns and high cohesion. So those of you who know about SQL or SQL queries will recognize syntax inside of LINQ queries, but there are a couple of important differences. So the resources associated with LINQ are in a namespace called system.link, and you probably have that using directive. It was added automatically when you created your console application. Now here we have just some source of data. This is the simplest possible collection of data. It's a simple array, and I've written a small routine that generates random integers. So here's our first LINQ query, and the first thing I want you to notice about a query is that it is of a var type. So what this allows the compiler to do is to look at your data and draw its own conclusions about how to access that data. So again, we have separated the storage of the data from the access of the data. So the first clause of the LINQ query tells us where we'll be getting our data from. So we start off by saying in a line that's sort of similar to what a for each loop looks like. My data will be coming from number list, which of course in this case is just an array of ints. And each element of that data, each member, each datum, will be called candidate. And again, the compiler is determining, based on the content of number list, what the data type of candidate would be. So we don't have to type that ourselves. We allow the compiler to make that inference. I'll be dealing with the various pieces of data, and I'll call them candidate. And then for each of those candidates, I do some filtering. And so here I have a where clause. And we see that the syntax of a where clause is very much like a loop or an if statement. We have a couple of conditions. And so for each of the candidates in number list, I'm going to see if that candidate is either the same as, equal to 2, or if the candidate value mod 2 is something other than 0, which of course would have to be 1, because those are the only two possibilities for mod 2. So in other words, if the value for candidate passed those two tests, it's either equal to 2 or it's equal to 1, then I'm going to execute the select clause, which is to say I'm going to select that value. So that will create a subset of the data where that subset matches my pattern. All right, so the next thing to notice about LINQ queries is that this statement right here is a declaration, is not an execution of anything. In other words, the data at this point in the code has not actually been filtered yet. We've just created something that could filter the data. It's not until you actually reference the data as something that's supposed to generate a value that you actually do that filtering. So in this case, what we're going to do is we're going to catch a snapshot of the data by calling the toArray method. So I started with an array, number list, and then I filter that array using eliminate twos, as we talked about earlier, and then that generates a sequence of numbers, which I will then turn into another array and assign that to a brand new array called mostly odd numbers. Here's another example. Notice that as my data source itself, I can use a LINQ query. So here's a LINQ query. I'm creating a new LINQ query, and I'm saying that that LINQ query is equal to get your data from this LINQ query, where again every element is called candidate. So eliminate twos and threes ends up being a subset of eliminate twos. Again, based on the criterion that if the candidate mod 3 is not 0, so in other words, it's not divisible by 3. So there's an example of using a LINQ query in a LINQ query. Again, recognize that the LINQ query itself has not taken place here. I've not actually executed this LINQ query. This is just the definition of a LINQ query. And then here's another way to define your LINQ queries. And this one uses a slightly more complex structure. So once again, the thing in parentheses here is simply a data structure. How did I create that data structure? Well, I take another LINQ query and apply yet another where clause to it, further filtering. And then beyond that, I've got two more where clauses. So basically what I'm showing you here is there are a number of ways that you can both present your data. In other words, you could just have a regular data structure, or you could have a LINQ query plus a data structure, or you could put multiple where clauses in your LINQ query. It all works to create the same thing, which is I got data from a data source and it has a particular profile. And then to finish the thought, here's my LINQ query eliminate all, and it uses a LINQ query that eliminates, as you can see, the zeros, the ones, the twos, the threes, and the fives, plus it also eliminates the sevens. I could, by the way, have done this all in one LINQ query. I'm just showing you various ways that you can construct a LINQ query to do that filtering. So whatever syntax makes the most sense to you, that's the one to use. All right, so now we see actual uses of the queries. So we start off with a simple for each loop that prints out every number in the list. And then we use another for each loop to show you the numbers other than the even numbers and the twos. And so it's not until this location that that query actually gets executed. And then we've got the same thing here for twos and threes. So these are all the same. It's all a matter of executing the query. And then finally, for this example, notice that we can actually embed a LINQ query as a parameter. In other words, the highlighted code there itself is a LINQ query, but because it generates a data structure, just like the other LINQ queries did, we can actually use that itself as a parameter. So you'll notice this is where it's actually passed. This is the declaration of the method itself. And it just has to be something that will match IEnumerable event. The details of those parameters are beyond our scope for this particular discussion. The point is, I could use a LINQ query to create a data structure and actually pass that query as a parameter. In other words, eliminate all is the name of my formal parameter, but my actual parameter doesn't have a name. My actual parameter is anonymous in that it is a LINQ query that has no other name. And in fact, if we look at these LINQ queries that we've been creating, what these basically are functions. If you know about function pointers or delegates or delegate instances, what I'm really creating here is a small function. I'm not calling it a method because it's not a member of a class the way other functions in C# are, but it is in fact a piece of code that's written in a declarative sort of way. So this particular function, which of course is a LINQ query, has a name. It's called eliminate all. And as I said before, here's an example of a LINQ query, or function if you like, that doesn't have a name. It simply generates data, and then we pass that data as a parameter. Let's take a look at another LINQ example. So this one will be UFO sightings. For this example, I've created just a little bit more data. I've got an enumerated type representing the types of UFO sightings. I have a class called sighting event that has some basic properties in it so that we can manipulate the data in simple ways. But really what we want to look at is the program itself. So what I've done here is I've created an array of these UFO sightings to have something to work with. And we see, once again, the use of LINQ in sifting through this data. So this is the entire catalog of sightings, just as a for each loop. This one filters by year. So in other words, we go through the catalog looking for sightings that are between the years 1950 and 1959. Notice that we can order our data, order by sighting date dot descending. The default is ascending. Here's a for each loop using that filter. There are a number of extension methods created to manipulate data structures. We have another discussion of extension methods in another video for this section. Basically, the idea here is that we don't want to re-execute the query in order to find out certain data about it. So just like with any static method, which is what an extension method is, we don't want to execute the object, or in this case, call the function, in order to ask a question about that data. So that's why these are extension methods. So some examples of extension methods. Any, which returns a Boolean value, which indicates whether or not there's any data in the collection. Count, which tells you the number of items in the collection. First, which gets the first item in the collection, assuming that there is any that we've already tested for. Notice that with the order by clause, you don't have to order by an entire element. You can order by an individual component of that element. Here's the use of the distinct extension method, which eliminates any duplicate data. So in this case, if we have multiple sightings in one country, we don't need to see that country repeated several times. We just need to know that that particular country has had a sighting. Notice, just as we can create anonymous methods and anonymous queries, we can even create anonymous types. So this is an example of constructing a type, in this case composed of the sighting name and the sighting country. And so for this anonymous type, which includes, as I said, name and country, we can actually use that information as a selector. And finally, we can even create and name customized values. So in this example, we use the let phrase to create a variable description, which is equal to the sighting name, location, and country. So that's just an example of some of the things you can do with LINQ queries. And that's LINQ queries in C#.